Good morning, good afternoon, and good evening, everyone, wherever you might be. So today we're going to be continuing our little fun application of Angry Birds here. And so far, what we've done is we derived the projectile motion equations for x and y of the bird, right? So in the first place, why again are we doing this? Well, we want to find equations to determine the exact position of the bird. So our bird could be I don't know. Our bird could be here at this point. And so this corresponds. How do we make meaning to that point? Well, it has some x value and it has some y value. And so we want to create a function where given some time or after some time, the bird is exactly at this position. The bird is exactly at another position. So that's the idea. And our goal here is we want to hit the pig. So the idea is we want the bird's coordinates to be equal to x pig, y pig. So, okay, now let's continue. So we stopped here. Um, we found our horizontal motion. So our projectile motion for x. Now we just need to find y, which we already got actually. So in the previous video, we talked about integrating um, this velocity to get position. And I did a little bit of brief review on how integrating a velocity function or speed or velocity could result in some position or distance, right? And so we actually got our y of t, which is this thing right here. And so I'm just gonna copy that. So y of t is some initial velocity v naught. We multiply that by t, and then we subtract 1/2 gt squared. So that's our projectile equations. And this will help us determine the position of the bird at a given time t. Okay, so now we've determined that. Now let's think about our next step. Because the big idea here, the big picture here is we're trying to find some sort of formula, some general formula where if we're given 2 points, and basically those 2 points are where's the bird at? What's the position of the bird and where's the pig at? What's the position of the pig? We can then use those points, apply them somewhere, plug them in some formula, and it will give us a corresponding angle that we need, or maybe some velocity that we need in order for the bird to hit the pig. So just like in the Angry Birds game, right? So after we derive the projectile equations, now we want to find this thing called trajectory. So that was the first step, finding projectile motion equations. The next step is finding trajectory. What do we mean when we say trajectory? Well, I just Googled it. So trajectory is the path followed by a projectile flying or an object moving under the action of given forces, according to Oxford Dictionary. Basically, it's the path that in our case, it's the path that the bird takes. So let's look at this picture here. We have the bird. I'm gonna take this real quick. I'll take this. Okay. So our pig is there. Okay, let's say it has this point. Sorry for disrupting your nose. Let's say the bird starts at 0, 0, right? And now its trajectory could be, oh, it goes up, then goes down. Let's say X is the ground. That purple dotted curve thing, that's the trajectory. So it's basically the path. That's the path, right? So ideally, we want our trajectory to hit the pig. So probably something like, I don't know, like that. And then it hits the pig. And then we win, right? But that's not always the case. So that's also one thing we need to find. Some formula for getting the trajectory, not just the position of the bird. So basically, in our case, trajectory, we can actually use the definition in Google. Why not? Let's use that. The path followed by a projectile. That's the Google definition. So here our bird is the projectile. And the projectile will follow that purple path that we kind of drew. And so in our case, it's just from the bird's initial position, which we denoted as 0, 0. And ideally, we wanted to hit the pig, right? So that's what we want to do. Now, how do we find this trajectory, right? So let's say, okay, I start at 0, 0. I go somewhere up, and then due to gravity, I go a bit down, or I go down. And that's the trajectory. Now, how do we find that? Here we can see it's actually just a curve, right? This thing's a curve. If I trace it, nice. This is a purple curve. And basically what we can do, given some x, we have a corresponding point in y, right? So this is some point in the trajectory curve. Let's call it a trajectory curve. Now we want to find the function of that trajectory curve. And it's actually quite simple. Why do I say that? Well, we already have our projectile motion equations, right? We have y, we have x. So actually, what we want to do here is we want to make y as a function of x. So it's basically what we did earlier. Based on some x, we get a y, right? We get some y based on some x. So that's just the idea that we're trying to apply in math. And so it's a function. We plug in an x, we get a y. So that's what we want. We want to find y of x. And we're actually given this already. Why is that? Well, okay, let's use what we know. Um, let's use what we know. So we know these projectile equations. So we know x of t, so that's just v naught cosine theta times t, right? And we also know y of t. This is what? Oh no, I'm going to check. V naught sine theta t minus 1/2. Minus 1/2 gravity times t squared. Now we want to, so the idea, if we want y of x, then we want to eliminate this t. How do we do that? Well, from our first equation here, we can actually take out the t here, or not really take out. We can isolate the t to get an x. So we can sort of manipulate this equation, right? So how would this look like? Well, this is our given. X is this equation times t. We can actually divide v naught cosine theta to both sides. So this will give us our t value in terms of x. And now, since we have this t value, we can use that in our y equation, right? So we plug in for every t, we plug that in our y equation. So y will now become v naught sine theta times t. So times x v naught cosine theta, right? And now we continue. Minus 1/2 g, and then t, which is x divided by v naught cosine theta. And then we square that thing, right? So that's our new equation for y. Now, we can simplify this. So let's simplify. Actually, I'm gonna cut this thing. I'm gonna put it down here. Let's keep it organized. Okay, so we have y of x, which is this thing. Now we have y in terms of x. Now let's simplify. So this is going to be v naught. Actually, we'll cancel the v naught. V naught's going to be canceled. Oh, now my eraser's not working again. Nice. Oh, what is that? Weird. Okay. Sure, keep going. Oh, okay. What if I do this? Okay. Having some issues here. Okay. Now can I do this? Huh. What if I do this? Yeah, this is weird. Uh, okay. That's weird. Can I go again? Okay. Okay, we're good. Now we want to simplify. So here you can just cancel out the v naught. This will give us sine theta over cosine theta. What is that? It's tangent theta, right? So here we have x times tangent theta. And then we can say, let me think. Yeah, we just square everything that's here. So it's just going to be minus gx squared over our v naught squared and cosine squared. So we have the minus 1/2. Oh, I forgot the 2. 2 should be down here. Oh, what happened? Okay. Yeah, 2 v naught squared cosine squared gx squared. Yeah. So now we've simplified, and then that's basically the equation of our trajectory. So that's that purple curve that we want. So now we're done. That's it. That's for y of x. Next thing we want to do, we want to hit the pig. So I think this is the funny and fun part. So if we want to hit the pig, Well, we just say that our x value should be x pig and our y value should be y pig. That's what we want. And now we basically plug it into the trajectory equation. So we plug it in here, right? So we say y pig should be equal to x pig tangent theta minus gravity x pig squared all over 2 initial velocity squared cosine squared theta. There we go. And what does that equation tell us? Well, it tells us that we have our pig position. So this is where our pig is. Yeah. What else? We have our launch speed. So when our bird launches, after we eject him, or after we slingshot the bird out of the slingshot. After we release the bird from the slingshot, which is, let's actually write that down. So here we have pig position, or where it's located basically. I should have said location, but anyways. So we have x pig and y pig. We have theta. Theta is the angle, launch angle. So I'm gonna say launch angle theta. And we also have a launch velocity. So initially, what was the velocity when we launched the bird? Right? And how does that affect yeah, how does that affect the bird hitting the pig? Right? Because I mean, if we go, oh, why did I say theta? If we go too slow, then we'll probably not hit the pig, right? If we go too fast, then we'll probably go over the pig. We also need to take into account that velocity as well as the angle. If we aim too high, then we'll probably not hit it. If we aim too low, then we'll just hit ourselves in the ground, right? So we need to take into account those three things. Now, we can actually go two ways here based on what we have. So the reason why I have two unknowns here, yeah, because here we're assuming that we're given the location of the pig, but we also have in this equation the theta, the launch angle theta, and we also have its velocity. So we basically need to have all of that for it to work. So we can go two ways here. We can either solve for theta. So if you want to know how fast you can shoot the bird, then you can solve for theta. Given that we have a number for its velocity, right? Or the other way around, we could solve for its velocity given that we have a theta, right? But we can, yeah, we can solve for both, just make them general. So one way, so I can do this either way. From our trajectory equation, I can solve for, let's say, let's solve for theta, right? So based on this trajectory equation, well, I'm just gonna isolate everything in theta. That's all I'm gonna do. So I'm basically isolating theta. I'm getting a formula out of theta. But here we need, okay, so if we're solving for theta, we have to assume that x pig, y pig, and v naught are given. Oh, now we can just isolate theta. But actually, we don't need to do that. Yeah, because if they're given, we can just plug in the values here, plug them in, and then we get theta out of it. Or we could also solve for its velocity, but that's assuming we're given our pig's coordinates and we're given theta. So we only have its launch velocity left to deal with. So really, this is the end of the problem here. Maybe we can try plugging in some values just for fun. So let's do that. Let's say, for instance, I'm going to go back to the previous example here. I'm going to say, actually, let's copy paste the bird and the I like doing this. Let's do a numerical example. Let's just see this in action. So let's say, oh, I'm gonna copy the bird. Can I do that? Oh, copy the bird, paste the bird. Okay, bird is there. I guess. Um, I guess here, up there, and let's impose coordinates here. So here we're in the first quadrant. Let's do y. Let's do x. This point here, I'm gonna label it in blue, just so that it looks evident, is the origin. And our pig here is at the point 10, 2. So this is 10, this is 2. So this is at 10, 2. Let's actually take this out. Okay, let's put 2 here. Now, of course, we want our trajectory curve to, I don't know, go like that maybe. But we want to hit the pig. We want our bird to hit the pig. So what do we notice here? We can actually use our trajectory formula. So let's go ahead and use that. So I'm gonna copy paste that formula real quick. Oh my goodness, this is difficult. Oh, okay, we got it. What's weird is, yeah. You guys saw a while ago, like when I'm trying to copy paste that thing, the one that's being copy pasted is either above or below, which is totally weird. Okay, I'm gonna go here. I'm gonna paste it in red, and we're gonna apply that formula. So let's label what we're given in the problem. So our x coordinate of the pig is 10, right? Because it's at 10 here, x coordinate of the pig. And our y coordinate for the pig's location is what? 2? Yeah. And what else? Let's do a simple example. Let's say when we're trying to launch the bird, it's exactly 45 degrees. How realistic? So let's say here our theta is 45 degrees. So we're doing degrees here. So another thing we know, theta is 45 degrees. So we want to hit the pig. So we need to find our initial velocity, right? So that's what we want to do. And we can easily do that. or our velocity launch, I mean. So let's do that. So for our velocity launch, we just plug in everything. So y pig is 2 equals tan pig, x pig, 10, tangent of 45 degrees minus gravity. So this is 9.8, I believe. Yeah, 9.8. Don't ask me, ask physics. And then we have x pig squared. So this is 10 squared. And then we say 2. So here we're just plugging in some formulas. 2 V naught. So here we're trying to find V naught. V naught squared cosine squared of 45 degrees. And then here we basically just solve for it. Yeah, we solve for V naught. So we can do that right now. So we say 2 minus 10 tangent 45 degrees equals negative of this thing. Let's actually do it real quick. 9.8 times 100. We got 980. 2 V naught squared cosine. Let's actually solve this. Cosine of 45, 9-degree mode. Okay, it gives me some number that I don't know. So I'm actually going to look at the trig table. Hopefully it gives, what is cosine 45 degrees? Oh, it's, yeah, because it gives like 0.705 thing. Yeah, which is 1 over square root of 2. So at least we got a fixed number here. So this is 1 over square root 2. Okay. Now we can just keep solving. So tangent, oh, another one here. Oh, we square this thing. So it's going to be 1/2. 1/2. Oh, but then we can cancel this thing. So now it's going to be just this. What else can we do? Oh, we can subtract. So let's say 2 minus, what's tangent of 45? See, I'm not good at trig. Oh, it's 1. So 2 minus 10, this is 1, tangent of 45. So 2 minus 10 is negative 8. So we have this. Now we can divide by negative 1, so we get this. And we basically get this value. So V naught squared is 980 over 8. What number is that? 1222.5. And so V naught is square root of that. Is there a number for that, maybe? Yeah, it's approximately 11.07. Can't be exact here. So, yeah, meters per second. So the conclusion is if we want the bird to hit the pig, we have to launch at this amount of speed, or let's be specific, square root of 122.5 meters per second at 45 degrees to hit the pig. At 10, 2. So that's our conclusion. And we can do this in other ways. We can, let's say if we're given the angle and we're given our velocity, what's the 2 points? Right? Actually, it's kind of impossible to I think we can work it somehow. Or it really depends on what we're trying to find out. Or if we're given the 2 points, the pig's position. What's also if we're given the what was it? If we're given the velocity, then what's the angle, right? Another thing is um if we're given, let's say, um I don't really know. I don't know how to be creative with these problems. So basically we wanna make use of this trajectory formula to solve um some problems that we wanna solve. So yeah, um that was fun. Stupid but fun. Um, yeah, I hope you guys learned something, and I'll see you guys in the next one.